Good morning. In this video, I'm going to be talking about pointers. This is going to be a heavy video, a lot of information. So work with me here. Let me just jump straight to Visual Studio here. So the first thing we're going to know is what is a pointer and what is the point of a pointer. A pointer is a variable that you can create, and that variable will store the address of another variable. So what does that mean? Again, imagine we have a variable called num, and let's say we'll store 100 in num. Now num here is a variable, and that variable is a space inside the memory, and that space inside the memory has an address. A pointer is another variable from the same data type, by the way, that will store the address of num. So for example, if I want to create a pointer, I have to go integer ptr. Now if I just leave it like this is just a regular variable. To convert a regular variable to be a pointer, you need to put the asterisk character here. Now you have multiple options. You can put it this format, you can put it this way, or you can put it between them, so it doesn't really matter. It's up to you. I like to put it this way. Now this is again a pointer, and at this point this pointer doesn't hold any value, and you are not allowed to come here and assign this to whatever you want. It doesn't work that way. It has to be assigned to the address of any other variables you have from the same data type. That's one way actually to get the job done. So how do I assign the address of num to ptr? Well, you're just going to have to use the ampersand and you type num, which basically means give me the address of num, and then it's going to be assigned to ptr. Now if I come here and just say cout num, it will show me the value 100, and if I just come here and say ptr, it will show me the address stored inside ptr, which is actually the address of num. Now I understand now that until this moment you will say, what is the point of all that? And that's what I'm going to be answering in a sec. Now you can see here it's 100.0053F74C. Now this is again a hexadecimal numbering system, because the address, usually every one of those digits is basically 4 bits. And depending on the system, since we have 64 bits, so I'm guessing, I'm not doing the math right now, but I think this is 64 bits. Every single one of those digits is basically a 4-bit number. Now, what you need to understand also is every time you're going to run this program, the 100 will stay 100, but this address will change. So let's just have a quick look. Try to remember most of these characters. For example, 74C is the last 3 digits. 74C. Now let's run it again, and you can see they're changed. Why is it changing? Because every time you run the program, the operating system will search for a new space inside the memory to store num. And since that's the case, there will be always a new address inside the memory for num. So here it is. This is basically what a pointer is. A pointer is basically a space inside the memory where you can store the address of another variable. Now, what is the point of pointers? Well, there's a lot of applications that we use in pointers, and I'm not going to mention them all right now, just one time. I'm just going to wait as we go through this video, and I'm going to explain what they are. But pointers basically give you more control over the execution of your program. A lot of applications actually take benefits of pointers. We can use pointers with functions and with when you pass values to functions, and that's something we're going to be covering later. But the main idea here, that with pointers you have a better management of your memory in your system, and also a lot of applications are built based on pointers. Now, when you say management of the memory, what do you mean? What do I mean by that? Well, basically, when in some limited resources systems, when the amount of memory that you have are really limited, creating a variable basically Creating a variable basically means you're going to reserve a space inside the memory until the program is terminated. So let's say you need thousands of variables, or thousands of space reserved to save your memory. That basically means that memory is going to be reserved until the program is executed and terminated. Now, what if I don't have that number of resources? But with pointers, what you can do, you can reserve a space and then get rid of that space and use it for another variable. So instead of reserving 1,000 spaces for variables, you can reserve 10, and every time you're done with those 10, you can terminate them and reserve the same space for new variables instead of having all the variables reserved till the end of the program. I'm going to show you examples about that in a sec, but this is again what pointers are all about. Now let's just get into the basics. Now the first thing I said, one of the types of mistakes that people do is you are not, as I said, you're not allowed to assign values directly to PTRs. The operating system will not allow that, even though if you know that space inside the memory, but that space could be reserved for another program. And one of the jobs of the operating system is to keep your programs fully independent. No one have access to other program resources. So operating system will not allow that. Now, one of the other things that we should know here, we looked at this ampersand when we said this ampersand will basically give you access to the address of your variable, of the address of num. Now, look what I can do here. If I come here and type asterisk ptr equal 200, what I just did here, I am dereferencing Ptr. So what do I mean by that? That basically means I am going to Ptr to have access to the memory location or memory address of num, and I'm going to that memory, I'm traveling to that memory location, I'm changing the value. So the original value of that was 100, now I'm changing it to a 200. Now if I come back down here, let me just copy this and put it down here. If I run the program, you will notice that num is not 100 anymore, it's 200. Let me show you that really quick. And here it is, it's 200. Okay, now what is the benefit of what I just did here? That basically telling me that I can manipulate num without actually having access to num. If I know the address of num, then I can process num anywhere I want in the program. And this here is important because we know we have something called the scope of variables. And when you pass values on variables from one function to the other, sometimes we pass by reference, sometimes we pass by value or by copy. Now what I can do, I can use addresses. And if I use addresses, that will give me the freedom to have access to any variables that I want anywhere in my program without get restricted by C++ rules. So as I said at the beginning of this class, that pointers will give you a freedom. Pointers will give you access. And pointers is one of the concepts that's not available in a lot of other programming languages. Like for example, Java decided to get rid of pointers and they replaced it with references. And if you go deep down in Java and C++ and you notice the difference between using references compared to using pointers, you will see how powerful C++ is comparing to Java when it comes to this point. And I believe having pointers in C++ is one of the points why we are teaching C++ till this moment. C++ is one of the oldest programming languages, but that's still gaining a lot of attention these days. So this is again a very, very simple explanation about what is a pointer and how does it work. Now, I'm going to be moving on to something a little bit different. And every time I move to a different topic, I'm just going to put that divider here so you'll understand that we're moving to a different subject, it's a related different subject. So, now we said every time you create a pointer, you need to assign an address to it. And that's basically what I demonstrated here. Here is another applications of pointers. As I said, imagine you have only 10 memory locations or memory spaces that you can have for your program. And imagine you need 20 variables. So you have available 10 memory locations for 10 variables, but you have 20 variables that you need for your program. So again, obviously the number of memory locations that I have in my system are not big enough to hold the 20 variables that I have. What pointers will let you do is to create those variables, 10 of them, execute your program, run your program, and the moment you don't need those variables anymore, you can delete them and then reserve the same space for the other 10 variables. And that's basically one of the applications of pointers. And how do we get this done? Basically, we're going to come here and create a pointer. I'm going to call it PTR1, and remember, we have to put the asterisk. And you come here, type new integer. Okay, so this is again a pointer, but remember here I'm using the keyword new. This is basically dynamic allocation for memory. I can come here, for example, and assign PTR1 to 200 or 300. After that, I can see out that variable. We just treat it just like any other variables. PTR1 and line. And now imagine that, okay, I'm done with this PTR pointer, so I want to delete it. PTR1. Okay. Now, whatever space was reserved for PTR will be erased and will be free for you to come and create a new one. Integer asterisk PTR2, for example, equal new integer. And then you can come here and say dereferencing Ptr2 equal 400, and then you can show it on the screen. Asterisk PTR2 new line. So this is the beauty. I'm missing something, of course. Here I have to delete PTR2. Now let me just tell you one of the mistakes that you may make. Number one, you will forget about the delete statement. Now, why is delete statement here is very important, because otherwise there's no point of going through all of this if you're not going to delete it after you're done. The whole point of this application is that after you're done with the variable and you don't need it anymore, you can delete it from memory, so you will free that space to be used by other variable. If you forget to delete it, your program is going to work, but that reserve space was going to be there until your program is terminated. Until the whole system is shut down. So that's again one of the mistakes that people actually make when they they deal with pointers. Now let me just run it. Of course, you're not going to see any different. It's going to look like any other variables, 300, 400, just like that. Let me make sure that I'm recording. Yes, I am. Okay, now we're done with this topic. Again, after all, I'm going to show you some applications where I'm going to put all these concepts together into one concept and one application. Now, the third topic we're going to be talking about is the C string. Now, we know we can create strings, and we covered that before. So, C string, string name, for example. I'll just go, for example, I'll just type my name here. That's a regular string. Now, in C++, we have another type of strings. It's called the C string. And I'm going to come here and put that as a C string. Now, what is a C string? C string is basically an array of characters. Now, we talked about arrays, so let's go ahead and talk about array of characters. Even though, again, we're talking about pointers here, and we'll see the relationship in a sec. So I can go ahead and create the correct character. Let's name this one name1. And if I come here and type name2, now this is a single character. If I want to create an array of characters, we basically put it this way. Let's say 10, for example, and then after that, I can come here and assign my name to it. So you can see here, this is how traditionally we will create a C string. Well, an array of characters. Now, what we can do to make it a little bit different, I can create a pointer. And then here, oh, he doesn't like it. Oh yeah, I need to use the keyword new. Character. And then you're gonna have to tell me the size of it. So here it is. This is an array of characters, and I'm using the same concept. Now you can think about, oh, well, what is this? This is new. I'm going to talk about that in a sec, but just to let you know that we can actually create an array of characters, and this basically is predefined inside the C string. C string comes. This is not, but there's a lot of functions actually predefined in C string header file. Now I can come here and type name2 equal 0 and assign it to a single character, for example, Ahmed, and so on. This is one way to get the job done. Also, let's say I try this. I can come here and say equal, just showing you stuff here, semicolon, and you can see here he's complaining about this. You are not allowed to directly assign a value to a C string. That's something you should know. So you cannot do that. What if I want to do it directly? Well, I can come here and say character name, and this is something I'm going to be talking about in a sec, just to let you know. For example, 10 equal and semicolon. I want you to notice those two lines because we're going to be talking about them later. But this is very similar to this one. Here I'm creating an array. Here I'm creating an array of characters, but this array is different than this array. That's something you should understand. Okay, like I said, I'm going to be talking about that later. Now, what if I want to go back? Let's go back to this string here. What if I actually want to assign value to this name2 here? Well, to do that, this is what we can do. For example, I want to assign name1 to str, or I'll assign Ahmed directly. So here we have str cpy, and you put name2, and you put whatever you want to assign to it. Now Microsoft doesn't like this this function here, because Microsoft think you reserve 10 spaces for name2, but what if this one was more than 10 spaces? Even though it's not, but Microsoft will feel like this is not safe to do. So let's see if Microsoft decided to take this. I told you he's not going to accept that. So Microsoft decided that, well, you have two choices. You can go to the settings of Visual Studio and change it to ignore my concerns, or you can just type _s, and wait a minute, is it _s? I think he mentioned it somewhere. Well, he didn't mention it. This function variable may be unsafe. Yep, here it is, _s. Why are you complaining? No. Well, I'm using it. Doesn't take 2 arguments. Okay, how many arguments do you take then? And let's go, for example, 5. Is that what you're complaining about? Nope. Okay, this is new. It looks like I have no choices but to go and change the settings. And let me take this _s away. See, syntax-wise, there's no problems, but again, Microsoft doesn't like it. Yes. Nope. He's not going to show it, but let me run it again. I'll say no. str copy. What I'm going to do, I'm going to copy this. Just, I don't remember the settings for it. Consider instead to disable description. Okay. Here he's telling me where to go. You have to read the whole message. So I'm going to go here to my project, properties, showing me this message. Now I am supposed to be looking for use CTR. I think it should be here somewhere. Journal, no. language. I'm just going to Google it really fast. I don't want to waste time here. Let me copy that. Okay, somebody will explain that to me here. I'm getting that error. I know that. How do I fix it? Here it is. Quick fixes to add. So where do I go? Here it is. The following expand configuration properties. Okay, C++ pre-process. Okay. Pre-process. And he wants you to, let's go back. Preprocess, preprocessor definition, in the preprocessor definition add. Let's just do that. But it would be a good idea to add. Okay, which one of them should I add now? I'll just add that one. So preprocess definition. Click here. Yeah, edit. You go to the bottom. Add that here. And save it. Apply. Let's give this a try now. And it worked. Okay. So now if I come here and I will just say cout name 2 and line, you'll see my name's printed here. So here we go. This is what we call a C string, and I showed you here 3 examples of how do we create strings in general. This is the regular string. This is what we call a static array of characters, and this is what we call a dynamic array of characters. Now, whether it's static or dynamic array of characters, if you want to actually process those strings, you need to learn how to use functions. Those functions are predefined inside the C string header file. One of the questions that you may have, so since I have 2 types of strings, which one of them I should go and use? Well, if optimization and performance is what you're looking for, then you go and use a C string. C string is a primitive data type. It's closer to the programming language, so it will work faster. But as you can see here, a very simple assignment operator required you to call another function to get it done. So operations are not that simple and that easy with the C strings. String by itself, it's designed to be simple and easy, so that's why you need to understand how this works. Now, I can talk about this for an hour, but I don't want to waste more time here. You go back to the ZY book, and there's a whole section talking about the functions that we have. Now, in addition to str copy, we have strcmp comparison, and that can compare between, for example, name 1, name 2. This basically, why is he complaining about? Oh, name 2, sorry, and name 3. You cannot compare a regular string with a string, with a C string. So this will compare those 2 strings, since both of them are Ahmed, so that will give me 0, by the way. The str comparison return a negative value or a positive value or a 0. If the 2 strings are exactly the same, it's going to give you a 0. If they're not the same, depending on the alphabetic order, the moment there's a difference in the alphabetic order of these characters, you will get a value that could be a positive or could be negative, depending on the difference between those alphabetic orders. So we got that one. And we have another one, which is strcat, which basically I am adding one string to the other. So I can come here to name 2, name 3. Name 3 will be added to name 1. Since both of them are exactly the same, it's just basically going to show me Ahmed without spaces. Let me just go ahead and show you. If I put cout here, just to show you the result, and I'll do the same thing for this one. And line semicolon. Oops. Okay, let's just give this a try and let's see what's going to happen. And here we go, 0, Ahmed. Hold it, why is it? This is count, this is compare. Oh yeah, here, because I'm printing it on the screen again. So this is why I'm getting both of them. Let me take this away. Okay, so as I said, if you need more details about this section here, you can go and read about it inside the UI book. There's a lot of explanation about these methods and how do they work. I highly recommend everybody to go and have a look at them. Now, since I talked about the C string, it will make more sense to talk about arrays now. And what I want you to do here, I'm going to go back and talk about those two arrays, but we'll say with numbers. And before I get to that point, let's just talk about regular arrays, what we call static arrays. If I come here and say integer array 1, and I'll put the value of 10, this is me creating an array with the size of 10, and this is a static array. Static array basically means as you write the program, you need to tell me the size. Okay, that's something you have to know. Now, dynamic array 2 is, for example, I can come here and type size. Now, of course, he's going to complain about size because size is not defined. I can come here and say size equal 10. And now, of course, I have to tell if it's an integer. Of course, this is not acceptable, as you can see here. This is also a static array, so you can see here, I'm typing size, but he doesn't accept it. So if I want this to be accepted, I have to come here and change this to be a constant. And now it's working. So those two examples are basically what we call static arrays. You can create a static array by using literal number like 10 here directly, or you can use a constant variable. But both cases, that size need to be defined as a programmer writing the code. So the question is, what if I actually want the user to decide what would be the size? And this is basically what we mean by a dynamic array. Dynamic array is basically when the size of the array is going to be defined as the program is executed, not as you as a programmer writing the program. So here's what we can do. Let me just put new integer. Now, this here doesn't remind you about this part here. It looks like we're creating a pointer here. The difference here that we're going to do is we're going to actually come here and put size. And now I created a dynamic array. Dynamic array, as I said, is the array where the size is going to be defined as the program is executing. A static array, the size of the array is going to be defined as you write the code. Now, one thing that they share is when you create the array and you define the size, whether it's static or dynamic, the size that you're going to use, you're going to stick with it. Now, the size of array 1 is going to be 10. The size of array 2 is going to be 10. The moment the program executes this line, the size is going to be 10. It will never change. Put that in your mind for now, because we're going to see that this is a problem later on. Now, I want you to compare this with this. Where is it? Here it is. So this is also a dynamic array of a type of characters. Now, whether it's static array or a dynamic array, what you need to understand is an array is nothing but a pointer. That's a fact that you should know. An array is nothing but a pointer. So array 1 is a pointer, array 2 is a pointer. And we defined pointers, this technique. And now I can define a pointer in a form of an array, like you see here. So let me show you what do I mean by that. But just before I forget, this is extremely important. Static arrays are going to be terminated, and the program can free that space for that array, if it's a static, once the program is terminated. So by the time I get to the end of the program, array 1 will be erased. Now, what did we say about dynamic variables or pointers, like the one that I created here, I said that I have to delete it manually. So the same case is going to be for this array too. I have to come here and delete it manually. So delete, just for me to not forget. And I will call it AR2. Now this is not enough, because previously when a pointer was just a pointer, we just deleted it with this statement. But since I have an array, so you have to put it between square brackets. So this is one of the differences. Now let me just come back here and just type cout array 1, and let me put a space, and I'll just type array 2. What I'm trying to show you here is that array 1 and array 2 are nothing but pointers when I try to print them as they are. And here they are. This is array 1 and this is array 2, so they're basically just 2 pointers. Now let's go ahead and assign values to those 2 arrays, just to manage something and to show you something. If I come here and type 9870, I was able to do that. Now here I have to do it a little bit in a manually form. So let's just go ahead and type that array 2 of 0 equal, I'll just put, just like we did before, 9. What I'm going to do, I can use, you know what, I'm just going to go ahead and create a for loop for this. For integer I equal 9, I is less than 0, as long as I is greater or equals 0, I plus plus. I want to come here and say array 2 of I equal I. So I'm just trying to create array 2 to equal exactly the same as array 1 in this section here. Okay, so now let's just go back here and run this. Of course, you're not going to notice any. What are you complaining about? What did I do wrong? Access violation? Oh yes, because you cannot be less. It could be equals 0, but it cannot be less. Oh, my bad. I have to go minus minus instead of plus plus. That was my mistake. Let's terminate it, run it again. And here we go. We got the same results. Let me show you something here, which is extremely important. So this is a pointer, and this is a pointer. Now, if I dereference a pointer by using the asterisk, so if I dereference both of them, since this is an array, since this is a pointer, and we say every time you dereference a pointer, we'll give you the value. So I have those 2 arrays. If I dereference them, and we know that it's an array, so which value is going to be giving me? Basically, it will give me the first value. So I'm supposed to get 9 here, and I'm supposed to get 9 here. Let's run it. And you'll see 9. Why is it 0? Yes, because the first value here is 0. Oh, look at me. I mistake. Yeah. Sorry. This was my mistake here at this point. I'm assigning the values to this array in the opposite order of this. So I'm starting with the last one going. Basically, this is just like exactly the same if I just put it this way. As long as I is less or equal 9, I plus plus. So I'm assigning them to 0, 1, the opposite order of the first one. So this is why if I dereference array 1 is going to show me 9. If I dereference R2 is going to show me the first value, which is 0. So dereferencing the array will basically show me the first value inside that array. Now the question is, what if I want to have access to the second value? Well, here's what you can do. You come here and you add 1 to it. And that will take you to the second value. Let's do the same thing here. And that will give you access to the second value. Now I'm supposed to get 8 here, and here I'm going to get 1. And here it is, 8 and 1. Okay, so now let me just go back and go down. What I'm going to do, I'm going to copy this. And I'm going to change something. Instead of going array with dereferencing, array 1 of 1, array 2 of 1. Which basically, this is me trying to have access to the second item inside those arrays. And here it is again. So, the bottom line here is an array, whether it's dynamic or it's public, it's nothing but a pointer. Okay? And since we know what a pointer is and how do we deal with the pointers, we can have access to those items by using the addresses, just like I did here. Or for simplicity, you can just use the square brackets, and you will give the same exact results. Now also, what you need to understand from here is that you can create static arrays where you define the size as you write the program, or you can define the size as the program is executing. And we do that using the keyword new. Now remember here, every time you use a new with a pointer, you must delete it. And because this is not a regular pointer, we have to put those square brackets. And that's basically what's the difference between the static arrays and dynamic arrays. Now the lab for today, for this week, what I'm trying to, I ask you to create a class. And in this class, I want you to predefine a dynamic array. So this is something very similar to what you see here. And when I'm done with the execution today, I'm going to explain how is that possible. But in general, it's very simple. It's just very straightforward. How do I create a class of a dynamic array? Okay, now the fourth part, yes, I think we're the fifth part actually. 1, 2, 3, 4. The fifth part of this lecture is about pointers and functions. Again, this is something very simple. If I come here, and then after that, I'm going to talk about pointers versus references. I'm going to create a function, call it void, and we'll call it fun1, and I will send an integer. Let's call it num. I'm going to update this, by the way. It will just say num cout num and line, and then I'm not returning anything. Let's just keep it simple for now. I'm going to copy this. Let's create another one. Let's call this one num2. Okay, so here we go, num1 and num2. Let's go down here. I am going to create a variable, integer, let's say num1. Oh, let's call it number. Let's set num to 1. Now what I can do, I can call fun1, and I'll pass number to it. And I can come here. Why are you complaining? Fun1 is here. Oh, where is this B coming from? Let me see out number and line semicolon. So I'm going to pass number, which is 10, to num1, and it's going to print it on screen. So let me just come here and change num to be 20. Okay, and let's see out num again and line. And you know what I'm going to do? I'm just going to say a message here inside fun1 before, and let me copy this, and I'll just type after. Control C, after. And I'm going to copy this same exact thing, and I'm going to put it down here. So let's go back here to num1. I'm calling the function. I'm passing 10. Now remember, this is me traditionally passing num1 as a copy to fun1. Now if I run it, you will notice it's just going to show me, here it is, inside it's 10. this is before, this is supposed to be after. I'm going to change that. It's 20, but again, you can see here, number doesn't change, doesn't get affected by that. Let's just put after. Now let's put this as after as well. So as you can see here, by default, when I'm passing number, which is 10, to fun1, it's going to show me 10 here. And then after that, I change it to 20, and it's going to show me 20 here. But when I come back here to number, it's basically just going to show it as 10 because I'm passing a copy. Remember that. Now here's what I can do with pointers. I can come here and put define num1 as a pointer. Okay? And I can come here and dereference num1. I can dereference num1. Sorry, num. Dereference it again. Now what happened here, I am passing, this is a pointer. And since this is a pointer, I cannot pass number again because number is a variable, but I can pass the address of number. So I'm passing the address of number to fun1, and then I'm receiving it as a pointer, and now I'm changing the value that I'm dereferencing num1. So basically, this dereferencing basically I am having access to number directly. Now, this is the point of pointers again. You see here, number is defined inside the main function. And now I am inside another function, which is fun1, but still I have access to number1, and I was able to change it. And that's again one of the beauties of pointers. So let me run it. And here it is. So inside the fun1, before is 10, after is 20, and now you can see here number is updated by that. Now we can get the same effect if we use references. So what do I mean by that? I'm going to come here and say fun2 number. And then, now remember here, number is equal 20 after this point. So I'm going to come here and print it on the screen as well. Copy that, put it down. Now I need to go and change fun2, and instead of putting this to be 20, let's put it as 40. Okay. Now, if I just keep it as it is, as you can see here, nothing's going to change. I'm passing a copy, I'm changing the copy, and that's it. But if I define num2 as a reference, now remember here, this ampersand here has a double use. The first use, when you put it in front of a variable like this one here, this is me having access to the address of. But when it comes and you put it as a part of the declaration of the variable, you're creating a reference. Now, to understand the difference between num and pointers, references and pointers, as I said, with pointers, you have a totally independent variable that stores the address of another independent variable. Now, when you have references, basically, what do you mean? You're basically referring to the same space inside the memory using two identifier. Okay? Think about it as a person with dual citizenship. Okay? Both of those citizenships, those passports, basically are referring to the same person. Same thing here. Num1 is an identifier, and num here is an identifier, and number here is another identifier, but both of them are basically referencing the same space inside the memory. So basically that means if I change number1, num2 is going to get affected by that, and if I change number is going to be affected by that. Those two variables. Now let me just show you the result, and you will notice you will get the same effect. And here it is. Before it was 20, after it's 40, and now it's 40. So this here is just to show you how do you handle functions and pointers and functions and references, and what's the difference between them. Now, because we get the same effect, Java decided to ditch pointers and focus on references, which is okay somehow, but I believe pointers are more important in a lot of other types of applications. So here you have it. Now you know what's a pointer, what's a reference, and what's the difference between them. Now you as a programmer, when you write a code, you have the freedom to choose between them whenever you want to pass a value to a function, and you know you want to manipulate that value, and you want to keep whatever change is going to be applied to that value. Then you have those two choices. You pass it by, you pass the address, or you pass it by reference. Syntax here is extremely important. You can see here that I'm putting the ampersand here, so that basically means I'm passing an address. Here I'm not passing an address, but when you go to the font 2, oh, I'm receiving it as a reference, so now I know two identifiers are referencing the same spot inside the memory. And this will be the end of this part. Now, what I'm going to be talking about here is vectors, linked list, and pointers and the relationship between them. Now, a vector is something you have an idea about, and we're going to talk about it later with a lot of more details. But a vector basically is, let me just put it this way, it's a dynamic array. Where is it? Here it is. A vector is a dynamic array. So what's the difference between a vector and a regular dynamic array? Okay, the difference between them is very simple. When you create a dynamic array and you decide that the size here is 10, then it's going to be 10 until the program is terminated, or until you delete it, sorry. With dynamic arrays, with vectors, if you get to a point where you have more data than the reserved space that you have, vectors will automatically double the size. So as you add data to your vector, the size will extend. And there's no limits. You can add as much as you want. So just to demonstrate that concept, I'm just going to come here and create a vector. Include vector. Now if I go down and I create a vector, vector is template. We're going to talk about template at the end of the semester, so don't worry about that. Type of integer, and I'll just call it vic. Now this is my vector. I can initialize it. Like that. That's acceptable. I can have access to those elements just like an array. Sorry, not 10. Let's say 0 equal 10. That's how simple it is. So it looks like it's exactly like any arrays. Now, when you create an array using this format, what is that telling you? That's telling you that there will be 5 items in that array, even though you didn't specify it. But to initialize an array using this format, that basically means you're defining the size of the array to be 5 elements. Now, with vectors, this is going to be this case again. This is going to be a dynamic array with 5 elements. Well, here's what I can do. I can come here and say vec dot push back, and I'll put 10. So what am I doing here? I'm adding the value 10 to this vector. Now, traditionally with dynamic arrays, if you try to get this done, if you try to add an item to the end of your vector, your array, you'll get an error. You're past your limits. You're passing the boundaries. The size of the vector is 5 elements. You cannot have 6 elements in there. Well, with vector, you can actually do that. And as I said, the predefined size for vic here is 5. And when I was trying to add another value to it, Vic will realize that, oh, I just have 5 spaces. So what's going to happen? A new vector is going to be generated with a size of 10. And the values from the old vector were going to be transferred to the new vector. And there will be extra 5 spaces where I can add the 10, and the previous vector will be deleted. And that's how vectors works. So vectors basically came to solve a problem of the limitations of the sizes. Because with arrays, whenever you define the size, then that's it. That's the size. But with vectors, you have no limits. You can extend it as much as you want. Now that's a solution for that problem that I just mentioned. Now there's another solution which is basically called using linked list. Now, like the standard libraries also include a header file called list. Okay, now lists are a little bit more complicated than vectors. And to be able to have access to the elements of the list, you need to know what's iterator, and iterators are pointers somehow. At this section of this class, the ZY book decided that they were not going to go a lot deep inside the list. So they didn't even, I don't think they even mentioned that you have the include header file called list. They didn't want you to go that deep into it. But just like how I included Victor here, I can include another header file called list, and I can create a list. Now, list by itself, it's a long concept. And it's important to have an idea about what a list is. Now, list is built based on pointers. Now, here with the Victors, I know it's a single pointer, just like any dynamic array. But with list, it's a sequence of pointers. Now, here's what I want you to do. I am not going to repeat myself in this area. But I have a video that I provided you with. It's called Introduction to Linked Lists in C++. This is a 34 minutes video where I actually explain what is a list, how does it work, and how do we apply operations to list. This is something that you will cover in a lot of details when you take a class called data structure. But it's really important and a good idea to have an idea about what is a list and how does it work. So I am not going to spend another 34 minutes explaining what a list is here in this video. What I want you to do is to go stop at this point, for example, and go check this video and have a look at it and then come back to continue. Now, also, I posted a file, the same file that I have in the video here, just to show you how does it work. And this is basically what is a list. I explained in details every single item in this list and how does it work. So it's a really good idea to have a look at it and look at this video. I'm not expecting you, the assignment for this week, it's all about linked list, and it's going to ask you to complete some file that has been given to you. And I also posted 2 videos to help you with that assignment. So go ahead and have a look at those videos and then come back to me to continue with the lecture of the class of today. But a linked list is, in general, it's basically a list of nodes, and those nodes are connected using pointers. That's how simple it is. But again, there's a lot of details that you need to understand when it comes to a linked list. I highly recommend everybody to go ahead and have a look at this video and have a look at this file and see where you can go with it. So let's go back to my Visual Studio here. And let me just write a comment here. Check the linked list video and the linked list CPP file at this point. Okay, so we're getting closer to the end of this video, by the way, so let me just go ahead and talk about something not really related to the concept, but I don't know, the ZY books like to jump between topics. How the memory is going to be controlled by the operating system. And this has nothing to do with the programming, but mainly whenever you have a program that is executed, there will be 4 regions saved inside your memory for that program. And those regions are code, static memory, the stack, and the heap. Okay? So remember, you have 4 regions inside the memory. Every time you have a program that is executing in your computer system, there will be a space reserved for that program. That space inside your program is basically divided into 4 sections. The first section is called the code section. The code section, from the name, it's the place where the program instructions, the file that you see in front of you, will be stored at, which is the instructions. The second region or zone is basically called the static memory. Static memory is basically all these variables. Let me show you those variables. For example, num1, not pointers. Remember here, this string is going to be reserved in that space. Not pointers. Remember, size is going to be stored in that space. Integer I is going to be stored in that space. Number is going to be stored in that space. So those are what we call static variables, are going to be stored inside that static memory. Now the stack is basically every single function you have in your computer will have a stack space. So for example, there's this num, since this is a pointer, this num here is going to be stored inside a stack. Stack is basically, again, a space where you store your local variables for each function individually. And finally, we have the heap. The heap is the part that we are concerned about. Every time you have the keyword new or delete, that's basically going to be stored. Any variable that is generated using the new keyword is basically going to be stored inside that heap. And that heap will not be automatically deleted, just to let you know. You have to manually delete it. So that's, again, how the memory is basically organized by the operating system. Okay, now one of the things we have an issue with, why do we need to delete? That's extremely important to understand. Because I said that at the beginning, is that the operating system will free the code space, and will free the static memory space, and will free the stack memory space as the program get to the termination, to be terminated. But the heap will not be deleted. And if you don't delete it, it's going to be there until the program is shut down. And again, this is something you're not only affecting yourself, now you're affecting other programs that's executed by your computer system. So this is something you don't want. Now, other programming language realized that this delete statement, since you're not going to be seeing the results of the deletion, you cannot sense it, you cannot see it, a lot of people like to forget it. So Java came as the hero of the day to help you out here. And Java has, and other programming languages has, like C#, for example, they have something called a garbage collector. The garbage collector basically has a job to always check the heap, and every time there is there's something inside the heap, the moment the program is going to be terminated, the garbage collector will go and free it up for you automatically. But again, this is C++ class. We don't have garbage collectors. So again, this could be one of the questions. What's the difference between Java and C++ when it comes to memory management? Here it is. Java has a garbage collector. C doesn't have a garbage collector. So that basically means I need to manually delete every dynamic memory allocated process that I performed. Now I'm going to be talking about the last topic, which is two topics to be specific, and this is going to be related to the lab that we're going to be working on. And because I'm going to be doing that, let me just go to the top here. And I'm not going to answer the question of the lab, but I'm just going to give you some piece of advices that could help you with the lab thing. I'm going to create a class. I'm going to call it my super class. Okay? In my super class, I'm going to create an integer, private. I will say integer, and I will say it's a pointer, and I'm going to call it my super pointer. Okay, now it's a pointer. It's just a pointer. And here, public. And by the way, this is very, very similar to what the lab is going to be all about, with a little bit of twist that you're going to have to figure that out by yourself. I'm going to have my superclass constructor. And let's go ahead and keep it that simple. Well, you know what? Yeah, let's just create two of them. Integer x, and then I'll just go ahead and type void print, and let's put semicolon here. And I forgot something which is extremely important in this case, my destructure. Okay, so let me just execute those lines of code. Remember here, my super pointer here, I need to assign a value to it in my constructor. And if I want to do that, this is what we can do. I cannot come here and dereference it. Like I cannot come here and say, Control C. I cannot come here and say equals 0. That would not work. Even though he's not complaining about that, but it should not work because again, this is a pointer. And because it's a pointer, I cannot directly assign a value to it. So what are we supposed to do here? We're supposed to do the following. Integer. Integer. And now I can dereference it and set it to 0. Now this basically will be applied exactly like what we had here. So I can copy this, Control C, put it here, but instead of 0, I'm going to put X. Okay, now for the print function, I'm just going to dereference. Oops. Nope. Control C. Let's dereference that. And line, semicolon. Okay, so I got everything done except this part. Now, traditionally, we will leave the D structure empty. But this is a case where you should not leave it empty. Now, because I'm using the new keyword here, that basically means I need to use the delete keyword somewhere. And because this is a dynamic variable that has been created inside a class, the only place to delete this variable is going to be the destructor. So this is again a point where the destructors are actually important. Previously, in all the destructors that we had before, it's basically not going to do anything because it's going to call the function. It's going to call that. It's going to free the space of that object that you created. But again, you leave it empty because that's basically automatically is going to assign to be called by the operating system to free that space from the variable. But again, if you have a dynamic variable, a pointer with the keyword new defined inside a class, just having the empty constructor will not free this space. So this is where you have to come here and say delete, and you have to put what you're trying to delete. So this is again important. Now the lab of this class is basically asking you to create a dynamic array. And instead of just a variable here, he wants you to create a dynamic array. And in that dynamic array, basically, instead of just having the pointer, you need to have a variable to represent the size. And here, inside the default constructor, instead of assigning the size to a value that's going to be passed, but basically nothing's going to be passed, you're going to have to ask the user to define the size of that dynamic array here. And then after that, you're going to have a function to assign values to those pointers. So this part here, could be the starting point that you can use to get the lab of this week done. You just have to modify it a little bit, add the size variable as a private, and then include that size variable when you call these constructors. One of them is going to be, for the default one, you can ask the user to define the size, and for this other one, you're going to have to pass it to that constructor. And then after that, you're going to have to populate the array, print the array, and don't forget to delete that array. The point here of this section here is this part, delete that variable. So every time you have any form of pointers using the new keyword, you need to delete it using the D structure. So that's a very, very important concept. Now, the last part I'm going to be talking about today, which is, let me save my work here. Let me just run it. Make sure it works perfectly fine. Okay. It's working. So let me just close this and let me go ahead and open. Let me just create a new Visual Studio. I don't want to delete this. I'm going to upload this file later. So let's go ahead and create a new project. Uh-oh. What did I click on? Create. This is going to be empty. Let's go ahead. I do have, there's a section, extremely important section, that I decided that I am going to actually write a code and show you it instead of me typing all this while I'm recording the video, which basically going to make it a little bit long. So here it is. This is my file. Now, what do I have here? Let's just look. This is something related to the last class. We were talking about operator overloading, and we had an issue, and the program didn't work for some reason. I just typed it here. The problem that we had last week was about the copy constructor. The copy constructor need to have the keyword constant here, which I forgot to put, and that was the reason why we had a lot of issues. But here it is. Let's look at this section here. I have a class, I call it my class, that has a regular integer variable. Now, I'm not talking about pointers here. I'm putting the pointers on the side. So let's look here. I do have my class. I'm assigning num to 0, and this is my class, me assigning num to num. That's traditionally normal. And now I have my destructure, I have a print, I have a num function, and I have an extra function here. Those are methods, and this is extra function, which is empty. I don't want it to do anything here. But what you need to understand about the test function here is that I'm passing temp, which is an object of my class. So let's go ahead and look here. What do I have? I do have a very simple object 1. I'm assigning object num to 10. This is going to print 10. Object 2. Oh, look at this. I'm passing object 1 as a member to object 2. Now, if you look here, I do have a copy constructor here, but I take it out. I just commented it out. Yet here, he's not complaining about, it looks like I'm using a copy constructor here, but he's not complaining about the copy constructor doesn't exist, even though I'm commented it out. So this will work, no problems. And you will see that object 2 will be assigned to 10. Basically, C++ will generate that effect for you automatically, and it will be acceptable. Unless you wanted to do something different, you go ahead and write it this way. So what I did here, just to make sure that you understand that they are totally two different objects, I came to object 1 and I changed it from 10 to be 20. And then I asked to print object 1, which is going to show me the new value, which is 20, because I got a setter here. And then I got object 2, which is going to show me the value, the original one, which is 10. So object 2 will not get affected by this change. What I'm trying to say here is, and let me just run it. I'm just going to show you the first two values. Actually, four values. Oops, what are you complaining about here? Oh, I just found it out. Here it is. Main 3. My bad. Go back. Yeah, here, main 3. So let's just go ahead and save it. Again, I'm only concerned with the first. You can see here 10, 10, and then I changed the variable 20 to be 10, 10 to be 20, but the second one didn't get affected by that change. So that's what I'm trying to show you here. So in this example here, as I said, my class, I have my class. This is my num. This is all the definitions. Now in this part here, I'm creating two objects. I'm calling the copy constructor here, but again, I'm commenting the copy constructor. So C++ will manage to get the effect that you're hoping for to assign object 1 to object 2. Now you need to understand this assignment is going to be done using what we call a deep copy. Deep copy basically means I'm going to have two objects with two different variables, and even though they're going to share the same values, but they're totally two different variables. And that's what we mean by copy constructor. Now here, in this case here, I actually tried to assign object 2 to object 3 using the assignment operator, and it worked perfectly fine. Now I will show object 3 printed as whatever object 2 is, and then I decided to change object 2 to 20. And remember, object 2 was 10 at this point, so I will check to see object 3 and what does it equal like, and you will see that still independent. So let's go back here. You can see now it's 10. So this is 10, 10 for the first one, then 20 and 10, and then I assigned, look at this, I assigned 10 to object 3, so it shows 10, and then I change object 2 to be 20, but object 3 is still 10 with no change. After that, I decided to create a third object, a fourth object, object 4, assign it to 100, and then after that, I decided that I will print object 4, which is 100, and then I call the function test by passing temp to it, and then I printed object 4 again, and it's showing me, it's going to show me 100 with no change. So again, let me just run it. You see here the program executed as expected, no errors. And also here, if I take this deconstructor away, take this part away, and I showed you two options here. I can take num from other and assign it to this, or I can immediately just say other equal asterisk this. This basically will give me the exact same effect. Whether it's this part or this part, I get the same values, no change. Now the point here, what I'm doing here is just to show you that when I declare num to be a pointer, the whole thing is going to change. Okay, so I just want you to have a look here. This is just me assigning objects to other objects, passing an object to a function, and it's working perfectly fine with no problems. As I said, when it comes to pointers, the whole thing will be changed. So let me just go ahead and copy the pointer section, and I'm going to have to explain a lot of what's going on here. So let me just go ahead and Control A, take that out, Control V. Let me make sure that yep, here it is. Put main instead of. So let's go. What I'm going to be doing here, let me just comment the whole thing here. And I'm going to go step by step to show you the effect of having pointers in this area here. So here it is. This is my num as a pointer. So I'm going to go ahead and use the new keyword, and then I'm going to assign it to 0. Here I'm going to assign it to num, and I'm going to have to go and use this format. I decided to comment again this constructor, copy constructor, and I have the destructor. Look at this destructor. This time it has delete num, and those are the same thing, just to show, and set num, and this is my function test num. So let me just copy this, take this away, and go and put it here. So I created an object 10, an object 1 with 10, and I passed it. This will work with no problems. And you can see here it's working. Now, the problem we're having is when you want to do a copy constructor. Oops. Remember previously I commented the copy constructor and it worked. But now remember we're dealing with pointers here. And the program's going to crash. So this would tell you that when you deal with pointers, you have to have a copy constructor whenever you want to actually assign an object to an object. And for that reason, this will not work if you don't have a copy constructor. So let me take that away, take that away, take that away, take that away. And this is what I'm doing here. New equal new integer, and then the dereferencing num equal the other num. Now, if I run the program, it will not complain about anything. 10, 10. And that also is going to be applied to, and let me just show you, if I cut this part from here and I put it down here, let me take this away. Now I decided that I'm going to change object num1 to 20, and how is that going to affect object 2? Just like we had before, they're totally two independent. So here 20 and 10, no change. Now the third example here is just to show you that. Let's go back here, take this out. So let me just take this one away, take this one away, take this one away, take this one away. Let's take this one away. Now you can, let me just run it, and you'll see that I'll get an error. Oh, actually, that worked. Why was he complaining about it then? Oh yeah, sorry, because I fixed the copy constructor, so the assignment operator worked. My bad, there's no error. And here it is. So this is 1020, this is 2020. So it worked perfectly fine with no problems. Let me just go down. Again, just because I have the copy constructor here, now I can use the assignment operator with no problems. So by having a copy constructor with pointers, I was able to make this line work and to make this line work with no problems. Now the last part is going to be this one, where I created, let me take this error away. I created a new object, object 4. I assign it to 100, and I'm going to print it. And then I called a function called test object 4, and I'm passing it here, even though it's empty. Okay, this is not going to work. Previously, it worked with no problems, but now it's not going to work. And let me just go ahead and show you if I decided to change. Let's just go ahead and do something here. For example, I'm passing. So I can come here and say temp dot. Again, I cannot have access to the valuable num because this is another function. So what I can do here, I can come here and say set num, and I'll set it to the value of, what was the value that originally had? Was 100, so I'm going to put 400 here. And put semicolon. Okay, so I decided to change the value to 400 inside that function. Again, I'm passing object. Let me run it, and it's still 100. No change has been applied. Why is that? Because again, you're passing object 1 as a copy here to this function here. But again, if you keep this one empty, let's see what's going to happen. Well, actually it worked. Oh, that's weird, because it gave me an error previously. Maybe I was just... But the point here is, in this function here, what I'm trying to do, if I am going to try to change the value here, and if I pass object 1, let's receive it as a reference, or you can have it as a pointer if you want to. So let's just reference it. So let's change, now let's run it. And you can see now it's getting the effect that I'm looking for. So again, this is not the biggest deal, but the most important part is this assignment operator and this copy constructor. As you can see here, previous example, when I decided to comment my constructor, it worked. But here, you need to have a copy constructor whenever you have pointers in your file. So this will be the end of this really, really long video, and if you guys have any questions, just send me an email, and don't forget to check the linked list video with the files. So have a good weekend.